ASP.NET Core has built-in types and helper methods to assist with returning different kinds of responses. In ASP.NET Core MVC, there are three main return types that action methods support. First, you can return a specific type, like a customer or a list of customers. Second, you can return an iActionResult interface. Or third, you can return an ActionResult of T generic type. And of course, in all these cases, you can return an async method that returns a task of this type. Specific types can be primitives, like integers or strings. They can be complex types, like data transfer objects representing an author, customer, order, etc. They can, of course, be collections, like lists or dictionaries or arrays, or simply IEnumerables, or even IAsync enumerable of T if you prefer. A benefit of returning a specific type is that it is strongly typed, so it is easily understood by automated documentation tools like Swashbuckle or NSWAG, which can generate a Swagger document, and of course it's also very simple to simply return the type that you're expecting to come back from your API. The biggest downside is that you cannot easily return any other response code or type. Now, speaking specifically about async, when we're talking about IEnumerable returns, or any type of collection that might be returned over an extended period of time, there is a definite performance benefit that you get by not buffering that entire list on the web server and then sending it over the wire. So if you have the opportunity to use IAsync enumerable, this will allow you to avoid that buffering and just send each individual item as you receive it. Here's an example of what using IAsync enumerable might look like. When you return a method that is IAsync enumerable, the method must be marked as async and should return individual instances using the yield return keyword combination as shown here. So it's going to return individual product instances one by one as it receives them from whatever data source it's using. One operation that is supported by this scenario is the application of in-memory filtering or business logic. As you can see here, we're doing a check to see if product that is on sale before choosing whether or not to return it. Normally, filtering is better done closer to the data source, but sometimes it will make sense to perform it in your application, and this provides a way to do so without buffering the results in a collection before you return it. And again, this can be important for performance as well as keeping the overall memory footprint of your application down to a minimum. If you choose to return IActionResult, it is a more flexible return type that was first introduced in the early versions of ASP.NET Core. It works with the built-in helper methods that are exposed by the base controller classes available in ASP.NET Core MVC. When we think about IActionResult, in addition to being able to use the built-in helper methods, you can also standardize on this so that you have a consistent return type that you use for every action method. However, it does have the drawback of not being strongly typed. So if you want to use a tool to generate Swagger documentation, you will typically need to add attributes to inform Swagger about what exactly you might be returning. Here's an example of an action method that returns an IActionResult, and because it's not strongly typed, the produces response type attribute must include the type being returned, in this case, author_DTO. When you open this up in Swagger, this is what the attribute allows Swagger to display as the response expected for this endpoint. If you decide to use the ActionResult of T result type, it supports returning objects directly, as well as the use of the built-in helper methods. It kind of offers the best of all worlds, and because of that, it is the recommended result type to use for just about every scenario. As you can see, it provides a combination of the benefits of using IActionResult and specific types. The only real downside left here is that you may still have to use produces response type, unlike if you were just returning a specific type, but you won't have to specify the type. So here's an example of what that might look like. In this example, we're using an action result of author_DTO, and so we can specify that this returns a status code of status 201 created, but notice that in the attribute, we no longer need to specify the type of the object being returned. That can be inferred from the action results generic type parameter, in this case author_DTO. Minimal APIs offer a slightly different set of abstractions from ASP.NET Core MVC. They introduce a new iResult interface, which is similar to iActionResult. They also have the ability to return specific types or just raw strings or JSON results. If you're using iResult, it offers many built-in options for common use cases, which is similar to how the ActionResult types are supported by ASP.NET Core. Now, let's look at some examples of response types, as well as how they're represented in Swagger by default. We're going to look at some controller actions for this and show what the different types of responses will render in Swagger. Each one of the endpoints is going to be named based on the return type that it is providing. So one of these is getObject, another one is getObject where it actually returns null. Then we can return a string. In this case, we're going to return JSON as the string. They're all basically returning a sample of a book. We'll see that in just a second. We can also return a JSON result with the book. We can use an iActionResult, or we can return an action result of T. The data is simply a book DTO with an ISBN number, a title, and an author. When we go ahead and run this code, it will generate a Swagger document that we can use. You can notice from the Swagger document that we don't have a whole lot of information about what's being returned in most of these cases. So when we go to get an object, or null, or string, or JSON, or even iActionResult, there's no information here about what's returned, and we haven't added any additional attributes to tell Swagger what those return types might be. But without even doing that, the strongly typed getIActionResult of T does show us what it's going to return back. Now, one thing that we could have is something that actually returned a book DTO, and that would also have given us that strong typing. But for reasons we already covered, we don't want to do any of those other types because they don't allow us to return a 404 not found response or any other appropriate result type if we don't want to just return the actual object that we're expecting to return back. A couple other things to notice is when we return an object, we do get it serialized as JSON. By default, it comes back as a 200 OK, and the content type is set to application JSON. If we return null from an object, however, we don't get anything back. When we execute it, we just get a 204 no content. Notice that the content type is not set at all because there is no content. There is no body of the response. So some clients that expect to always have JSON, and maybe they're expecting to get back an empty JSON result in the case of null, might be thrown off if you're returning back a no content. When you return a string, you do get the data back that you would expect, and here is our JSONified data of the book, but notice that the content type here is text plain. So when you return a string, by default, it's always going to come back as text plain, which again may not be what you want. If we are trying to get back a JSON result, this will work as expected, and you'll see the content type is application JSON. That's going to be the case when we return the same thing using our iActionResult, and you'll see here it's identical. It's a 200 response with content type application JSON. And finally, when we do application iActionResult of T with the same thing, we get back the same result. The biggest difference being the documentation that you get in Swagger. That's all using controller-based APIs. Of course, we now also have support for minimal APIs. Let's take a look at what that would look like. In the case of a minimal API, we can map a response like this. In this case, it's just mapping it directly to the objects coming back from the entity. In addition to defining APIs inside of your program.cs using mapget there's also a number of packages you can use to put those API endpoints into their own classes, which is my preference. One of the ones that I'm using here for the author create endpoint is called minimalapi.endpoint. Using this package, your classes need to implement the iEndpoint interface, and that's going to then give you the ability to set these two methods, the addRoute method and then the handle method. Obviously, the route is where you specify how you're going to wire things up to your actual endpoint, and then in the handle async, that's where you're going to do the actual work of the request. Now notice in handle async we are using a task of iResult, which is the recommended approach when you're using minimal APIs. And when we are returning that result, we're using results dot to specify what we want to return. And since this is a post, we are creating a new endpoint. We're going to specify that it was created. We're going to note the URL where you can find that new resource. And we'll also return back in the body the newly created resource as well, just so that we can save an extra round trip for the client that's using this API. When we look at what this is going to generate in the code, here's the generated code from the minimal API for that post. We can try it out and see what happens when we go to create it. One of the things that I want you to notice is that it is strongly typed. So the schema for the request includes the create author request, and for the response, you can see it's the author created response. Those both appear down here as well in the list of schemas. Now when we try this out, if we specify a name and an alias and run this, what we should get is a new resource, in this case ID 6, and also you'll notice that it is providing us with a location header specifying that it is also available from /authors/6. This should give you a pretty good understanding of how to use the different response types that ASP.NET Core offers, whether you're using the controller-based MVC style action results and iActionResults and action result of T, or if you're going to use the new iResult interface with the minimal APIs. In this module, we quickly covered the principles of REST and how they apply to web APIs generally, even those that don't fully embrace REST features such as hypermedia. We learned about resources, which can be anything you can represent with an identifier, and how to design our web APIs around resources and their representations. Next, we learned about HTTP verbs or methods with a focus on those most often used by web APIs. We learned which verbs should be designed to be idempotent, safe, neither, or both. Then, we learned about HTTP status codes, again focusing on those most commonly used by your web APIs. We learned which status codes are most often used and which ones belong with which verbs or methods, as well as a few things to avoid. Finally, we saw how ASP.NET Core provides features to make working with response types easier, such as iActionResult, ActionResult of T, and for minimal APIs, iResult. Up next, we'll dig into web API models and how best to design them. I hope you'll join me. Hi there. Once again, I'm Steve Smith, aka Ardalis, and in this module, we're going to take a look at best practices and considerations for designing the models used by your web APIs. The models we're talking about here are the things your API accepts and returns over the wire, typically serialized as JSON or perhaps XML. Let's get started. In this module, we're going to start with some basic best practices for your web API models. Then, we'll introduce and talk a little bit about the robustness principle and how it applies to web APIs and the models you accept and return. Then we'll discuss how to decide what data your APIs should return depending on context, and then we'll look at some of the characteristics of good web API models, as well as some anti-patterns that might indicate that your models aren't as good as they could be.